In the vast cosmic ocean, our pale blue dot hangs suspended in a sunbeam. For all of human history, this fragile world has been our only home. But now we stand at the threshold of becoming something more, a multi-planetary species. Our destination? Mars. A world of rust-coloured sands, ancient river valleys, and towering volcanoes that could swallow continents whole. As we embark on this greatest of human adventures, we face obstacles that will test the very limits of our ingenuity and courage. The journey to Mars is not merely a test of our technological prowess, but a crucible for the human spirit.
Touchdown confirmed. Perseverance safely on the surface of Mars. Ready to begin seeking the sand.
Mars presents us with a striking paradox. At first glance, it seems almost welcoming. A planet with 24-hour days, familiar seasons, and polar ice caps that wax and wane like Earth's. Yet beneath this familiar veneer lies a world that challenges our very definition of habitability. The average temperature on Mars hovers around minus 63 degrees Celsius, minus 81 degrees Fahrenheit. Even at the equator during the warmest days, temperatures rarely rise above 20 degrees Celsius, 68 degrees Fahrenheit, only to plummet to minus 140 degrees Celsius or minus 220 degrees Fahrenheit at night. These extreme fluctuations pose significant challenges for both human survival and equipment reliability. The engineering required to create habitats that can withstand such temperature swings is phenomenal. Mars' atmosphere is a mere whisper compared to Earth's, just 1% as dense. This thin blanket of mostly carbon dioxide creates an environment where liquid water can't exist on the surface. Atmospheric pressure is so low that unprotected human blood would boil at body temperature, and essential protection from radiation is minimal. The implications of this thin atmosphere cascade through every aspect of human survival. Perhaps most dramatic are Mars' dust storms, which can grow to encompass the entire planet. Unlike anything we've seen on Earth, these storms can persist for months, turning day into night and challenging our every attempt at solar-powered exploration. The dust itself is insidious, fine particles of oxidized iron charged with static electricity that can work their way into every seal and bearing. We've learned harsh lessons about this dust from our robotic explorers. The Opportunity rover, after 14 years of faithful service, finally succumbed to a planet-wide dust storm that blocked its solar panels. To understand the challenge of reaching Mars, we must first confront an invisible enemy that permeates the very fabric of space: cosmic radiation. This constant bombardment of high-energy particles presents one of our greatest obstacles to long-term space travel and Mars colonization. During a typical 6-month journey to Mars, astronauts will be exposed to about 300 millisieverts of radiation, equivalent to over 300 chest X-rays. To put this in perspective, nuclear power plant workers are limited to just 20 millisieverts per year. This exposure continues on the Martian surface, where the thin atmosphere offers little protection against this cosmic onslaught. Two distinct types of radiation pose unique threats. First, galactic cosmic rays, particles accelerated to near light speed by distant cosmic events. These can penetrate traditional shielding materials, causing cumulative damage to human DNA. Then, there are solar particle events, intense bursts from solar flares and coronal mass ejections. These can deliver potentially lethal doses of radiation within hours, turning the life-giving warmth of our sun into a deadly hazard. Thankfully, recent research from NYU Abu Dhabi's Center for Astrophysics has revealed some potential solutions. Certain materials, including specific plastics, rubber, and synthetic fibers, as well as Martian regolith, show remarkable effectiveness in shielding against cosmic radiation. These findings could inform the design of protective habitats and spacesuits, making long-duration Mars missions more feasible. The most promising approach combines multiple strategies: active electromagnetic shielding, passive material barriers, strategic habitat design, and biological countermeasures, including anti-radiation medications. But how do we actually get there? The journey to Mars represents the greatest voyage humans have ever attempted. Launch windows occur only every 26 months, when the planets align favourably, creating a cosmic ballet that defines our exploration timeline. The trip itself takes 6 to 8 months, during which our Mars-bound pioneers will face challenges unprecedented in human history. SpaceX's Starship, standing 120 meters tall, represents our first true interplanetary spacecraft. With a payload capacity of 100 metric tons, it is revolutionizing our approach to deep space transport. This behemoth of engineering is not just a rocket, but a fully reusable system designed to refuel in orbit, carry large crews, and land on extraterrestrial surfaces. Its development marks a paradigm shift in our approach to space exploration, making the concept of regular flights to Mars a tangible possibility. NASA's Space Launch System, while focused on lunar missions, is developing technologies crucial for Mars exploration. The Artemis program, aimed at returning humans to the Moon, serves as a vital testing ground for systems and procedures that will eventually take us to Mars. This program is accelerating new technologies such as advanced life support systems and new spacesuits designed for planetary exploration. Each of these breakthroughs brings us one step closer to our Martian goal. Recent developments in nuclear thermal propulsion could also reduce the travel time significantly. These engines, heating hydrogen to extreme temperatures using a nuclear reactor, could provide twice the efficiency of chemical rockets, potentially cutting travel time to just 100 days. This reduction in travel time is crucial not only for minimizing radiation exposure, but also for mitigating the psychological challenges of long-duration spaceflight. This could turn an 8-month journey into one lasting just over 3 months, and that could be the difference between a harrowing ordeal and a manageable expedition. The human mind, perhaps even more than the body, will face unprecedented challenges during Mars missions. These first Martian explorers will be confined to a space no larger than a small apartment, while Earth shrinks to a pale dot in the window. Communication delays of up to 20 minutes mean that real-time conversation with loved ones becomes impossible. Every problem, every moment of joy or sorrow must be experienced with a profound sense of separation from the bulk of humanity and from the beauty and nurturing of Earth itself. Studies from long-duration isolation experiments have revealed the complex psychological landscape our Mars pioneers will navigate. The third quarter phenomenon, a period of increased stress and decreased motivation that typically occurs after the halfway point of extended missions, has been well documented in Antarctic research stations and could be particularly challenging during a multi-year Mars mission. To address these challenges, NASA and other space agencies have developed sophisticated countermeasures. Virtual reality systems are being designed to provide immersive Earth-like experiences and family interactions. Martian colonists may be able to walk through a forest or along a beach using this technology. And the hope is that the sensory experience is so real, it provides a vital psychological lifeline to Earth. The first Mars bases will be marvels of engineering, featuring multiple life support systems, radiation-shielded living quarters, automated maintenance systems, and emergency backup facilities. A typical Martian day, or SOL, might begin with morning systems checks and habitat maintenance. The base's life support systems, its lungs and circulatory system, require constant monitoring and adjustment. Oxygen levels, temperature, humidity, and air pressure must be precisely controlled, not just for comfort, but for survival. Greenhouse management and food production will be vital tasks. Imagine vast hydroponic gardens bathed in artificial light, producing fruits and vegetables that have never before grown in Martian soil. These greenhouses will be more than just food sources. They'll be oases of Earth-like environments, vital for both physical and psychological health. Without the constant pull of Earth's gravity, human bodies begin to change. Bone density loss in 0.38 g gravity, cardiovascular system adaptation, and potential vision problems from intracranial pressure are just a few of the physiological hurdles we must overcome. Limited medical supplies and expertise mean that emergency procedure protocols must be meticulously planned and practiced. Telemedicine may play a crucial role, with Earth-based doctors providing support and guidance to Mars-based medical staff. The key to sustainable Mars colonization lies in in-situ resource utilization. Recent studies have shown that Mars has abundant resources that can be harvested. Water ice deposits, particularly in the Korolev crater, could provide drinking water and be used to produce oxygen and hydrogen for fuel. The Martian atmosphere, though thin, is 95% carbon dioxide, a potential source for oxygen production and plant growth. Martian soil contains valuable minerals that could be used for construction and manufacturing. NASA's MOXIE experiment on the Perseverance rover has already demonstrated the ability to produce oxygen from Mars's CO2 atmosphere. This breakthrough is more than just a scientific curiosity. It's a proof of concept for the technology that will allow future colonists to literally create breathable air from the Martian environment. Scaling up this technology could provide not just breathable air for future colonists, but also oxidizer for rocket fuel, potentially enabling return missions to Earth. 3D printing technology, using Martian regolith as a base material, could revolutionize construction on Mars. From tools to habitat components, this technology could allow Martian colonists to manufacture what they need on site, reducing the need for supply missions from Earth. As we look to the future, we see the potential for Mars to become a second home for humanity. From those first small bases, we can envision domed cities rising from the Martian plains, vast terraforming projects turning the red planet green, and perhaps, in the distant future, a Mars with oceans and breathable air. Recent research has proposed using specially engineered dust particles made from minerals already abundant on Mars to create a greenhouse effect, potentially raising the planet's temperature significantly in a relatively short time. This innovative approach represents a shift from traditional terraforming ideas, offering a more feasible and cost-effective solution. Imagine a Mars slowly warming, its ice caps melting to form seas, its atmosphere thickening to protect the surface from harsh radiation. The technologies and human adaptations required to live on Mars will pave the way for journeys even further into the solar system and beyond. The challenges we overcome on Mars, from radiation protection to sustainable closed-loop life support systems, will be the foundation for humanity's expansion throughout the cosmos. The first child born on Mars will be a milestone in human history, a child whose first sky is pink, whose first horizon is a stark Martian desert. This child will grow up in a world where the impossible has become possible, where human ingenuity has overcome the harshest environment we've ever faced. Standing here on Earth in 2024, looking up at that red point of light in our night sky, we are closer than ever to making this dream a reality. The journey will be perilous, the challenge is immense, but the human spirit has always risen to such moments. The journey to Mars is more than just a technical challenge. It's a test of our species' ability to cooperate on a global scale, to think beyond short-term gains, and to envision a future where humanity is not bound to a single planet. Mars is calling, and humanity is ready to answer. The greatest adventure in human history awaits us on the red sands of our neighbouring world. As we reach for Mars, we reach for the stars. And in doing so, we reach for the very best of ourselves.